Hello friends, in the last video we have completed the questions 1 to 20. Now in this video we will consider the question number from 21 to 33. Now let us start the miscellaneous exercise for the sequence and series remaining question. Now let us start the question number 21. For a GP, if T2 is equals to 7, T4 is equals to 1575, then find the value of A. Now see this here, what is we have given? That is a T2 and T4. Now what is the formula for the Tn? Tn is equals to A into R raised to n minus 1. Now in this formula we will substitute the value of n as 2 and the value of T2 is equals to 7. Now see this, T2 is equals to A into R raised to 2 minus 1, that is AR is equals to 7, and the next is T4. T4 is equals to, again see this here, T4 is equals to A into R raised to 4 minus 1, that is A R raised to 3 is equals to 1575. Now next we will take the ratio of these two values. Now see this, therefore AR cube is equals to 1575. Now we have the two ratio, that is the two values, that is from first and the second. Now we'll divide the second by the first. See this, that is AR cube is equals to 1575 upon AR. Therefore in this case here RR get cancelled and we get R square is equals to 225. Therefore R is equals to 15. Now using this value, that is AR is equals to 7. Therefore substitute the value of here R. If we substitute the value of R here, which is the 15, therefore A is equals to 7 upon 15, and hence the value of A is 7 upon 15, and that is R is equals to 7 and A is equals to 7 upon 15. This is the answer. Now next question number 22. If for a GP T3 is equals to 1 upon 3, T6 is equals to 1 upon 81, then find R. Again in this case we will apply the formula for Tn is equals to A into R raised to n minus 1. Now see this, we have Tn is equals to A into R raised to n minus 1, and that's why T3 is equals to, we have given the first value T3 and hence we will replace here n by 3, that is a into r raised to 3 minus 1 is equals to a r square is equals to 1 upon 3. Now we will simplify next. That is a T6 is equals to a into r raised to 6 minus 1, that is a into r raised to 5, and that's why that is equals to 1 upon 81. Now in this case we have two values, that is a r square is equals to 1 upon 3 and a into r raised to 5 is equals to 1 upon 81. Now we'll take the ratio of these two values, that is a into r raised to 5 upon a r square is equals to 1 upon 81 upon 1 upon 3. Therefore, now in this case, on the left hand side, this a get cancel. R raised to 5 upon r square means what? R cube. That is equals to 1 upon 81 into 3. Now this is multiplied and reciprocal of this 1 upon 3 is 3 upon 1. And therefore, you will have the value r cube is equals to 1 upon 27. And hence r is equals to 1 upon 3. This is the value of r. Now next is question number 23. Find summation r is equals to 1 to n 2 upon 3 bracket raised to r. And now see this sequence, that is a 2 upon 3 plus 2 upon 3 bracket square plus 2 upon 3 bracket cube, and in this way here the first term is a is equals to 2 upon 3, r is equals to 2 upon 3 bracket square upon 2 upon 3, that is r is equals to 2 upon 3. Now next is, now the value of the r is mod of r is less than 1, therefore we apply the formula. Mod of r is less than 1, which is 2 by 3. Therefore, sum s is equals to 1 upon a is equals to 1 minus r raised to n upon 1 minus r. And in this formula, we have substituted the values. That is 2 upon 3 in bracket 1 minus 2 upon 3 bracket raised to n upon 1 minus 2 upon 3. Now see this next. That is a 2 upon 3 minus 2 upon 3 bracket raised to n, which is 1 upon 3, and these two terms get cancelled. This 3 get cancelled, and then you will get 2 in bracket 1 minus 2 upon 3 bracket raised to n. Now see these calculations. That is 2 in bracket 1 minus 2 upon 3 bracket raised to n, and we have this answer. Now next is, therefore, question number 24. Find k so that k minus 1, k plus 2 are the consecutive terms of a GP. That is, these are the consecutive terms. Means what? The first term T1 is equals to k minus 1, T2 is equals to k, T3 is equals to k plus 2 are the consecutive terms. Then find the value of the k. Now see this, T1 is equals to k minus 1, T2 is equals to k, T3 is equals to K plus 2. Now what is meant by R? R is equals to T2 upon T1, T3 upon T2, K upon K minus 1 is equals to K plus 2 upon K. Now we perform here the cross multiplication, that is a K into K is K square, and on the right hand side K plus 2 into K minus 1. Now see this, K plus 2 into K minus 1, that is a K square in bracket the multiplication of these two terms, that is a K into K, K square minus K plus 2K and minus 2, and we will simplify this. K square on both sides get cancelled, and therefore the value of K square get cancelled. Then you will get minus K plus 2K means what? K. Here is the minus 2, and that's why K is equals to 2. The value of K is equals to 2. Now, next, problem number 25. If for a GP, first term is 27 raised to 3 and seventh term is 8 square, find S8. Now we have given the term, that is the first term means what? The value of A is given, and the seventh term means what? T7 is given, and we want to find out S8. That's why now here A is equals to 27 raised to 3, T7 is equals to 8 square. Now the value of Tn is equals to A into R raised to n minus 1. T7 is equals to A into R raised to n minus 1. That is 8 square is equals to 27. Now substitute the value, that is here it's a value 8 square. Now we can see here again T7 means what? It is a 8 square and the value of n is equals to 7. Now simplify this, that is 8 raised to 2 A into, that is 27 raised to 3, and we have the value of A is 27 raised to 3 into R raised to n minus 1. Now again here we will simplify, that is R raised to n minus 1 is equals to 8, 7 minus 1 will replace there the value of n, that is R raised to 6 is equals to 8 square upon 27 bracket cube. Now see this value. Now we can write this, the value of 8 means what? 2 raised to 3 bracket square and 3 raised to 3 bracket square. Therefore you will get 2 raised to 6 upon 2, 3 raised to 6, 2 upon 3 raised to 6, and the value of R is equals to now this is the simple simplification, that is R raised to 6 is equals to 2 raised to 6 upon 3 raised to 6, and that is nothing but 2 upon 3 raised to 6, and that's why the value of R is equals to 2 upon 3. That is equals to 2 upon 3, and the value of A is 27 raised to 2. Therefore, Sn is equals to, we will apply the formula, that is the Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. The value of R is equals to 2 upon 3, which is less than 1. Therefore, here again we will substitute the value of A and the R. That is 27 raised to 2, 1 minus 2 upon 3 bracket raised to n upon 1 minus R, which is 2 upon 3. Therefore, the value of S 8. Now here we will replace n by 8. Therefore, 27 square in bracket 1 minus 2 upon 3 bracket raised to 8, 1 minus 2 upon 3, and simplify this. We will replace its value 27 raised to 2. Now see this, that is 1 upon 3. Now 27, I will replace it the value. Therefore 27 raised to 2, and in this way we have the calculation. This is 1 upon 3. It becomes multiplied and reciprocal, it becomes here 3. Therefore 27 raised to 2 into 3 in bracket 1 minus 2 upon 3 bracket raised to 8. Now next calculations is, that is 27 square into 3, that is 2187 in bracket 1 minus 2 upon 3 bracket raised to 8. This is the value of is 8. That is the sum of the 8th term of the given GP. Now, therefore, S8 is equals to 2187 in bracket 1 minus 2 upon 7 bracket raised to 8. Now the next question, that is a question number 26. Now, in this, the pth, qth and the rth term of a GP are x, y, and z respectively. Find the value of x raised to q minus r into y raised to r minus p into z raised to p minus q. Now we'll see this here. The fifth value, qth value and the rth value of the GP are x, y, z. These are the terms. Now here we will apply the formula t suffix p is equals to a into r raised to n is replaced by p, and the value of the pth term, that is equals to x. Therefore, t suffix p is equals to a into r raised to p is equals to x. T suffix q is equals to a into r raised to q minus 1, and t suffix r is equals to a into r raised to r minus 1, and that's equals to z. These are the given values. Now next, that is x is equals to a into r raised to p minus 1, y is equals to a into r raised to q minus 1, and z is equals to a into r raised to r minus 1. Now these two are different. We can take that value also k. Now in the next example, if the r is repeated, I had considered k is a ratio. Now first is x raised to q minus r into y raised to r minus p into z raised to p minus q. Now here we have the x is equals to a into r raised to p minus 1, then whole bracket raised to q minus r. And in this way we will substitute the value of r also and the value of z also. That is, the value of the r is y is equals to a into r raised to q minus 1. Then we'll make here bracket raised to r minus p. And next is z is equals to a into r raised to r minus 1, but here bracket raised to p minus q. Now see this. This is the value of x. We have substituted it and bracket raised to q minus r. Next, this is the value of the z. Now see this here. These are the value of the x raised to q minus r, because here we have given it q minus r. Value of the y raised to r minus p, here is r minus p. And the value of the z, it is a into r raised to r minus 1 and raised to p minus q. Now see this next. Now if we simplify this, then you will get the first, we will collect the a terms. Now here a raised to q minus r, here a raised to r minus p, and here a raised to p minus q. Now see this here. These are the values of a. Now next values are now see this. These are the next values of the r. Now r raised to p minus 1 into q minus r. Here again r raised to q minus 1 into r minus p into r raised to r minus 1 into p minus q. And now we will simplify this simple calculation. Now if we see this, that is the base is same, then we can add it. That is a raised to q minus r plus r minus p plus p minus q, and overall that is r raised to will be 0. Now see this calculation. That is a raised to p q minus r plus r minus p plus p minus q, r raised to p minus 1 q minus r plus q minus 1 r minus p plus r minus 1 e minus q. Now here r raised to 0. Now the multiplication, that is first two bracket will get the 4 terms, 3 terms, 3 and 3 and 3. That is the total terms will be the 9 terms. Now see this here. Therefore, now the multiplication. What is your multiplication? P minus 1 into q minus r. Here we will get the multiplication 1, 2, 3 and 4. Next multiplication is q minus 1 and the r minus p. Here is the next multiplication and the last multiplication. These are the 4 terms. Now next, simplify this. There is a pq plus pq minus pq get cancelled, plus pr minus pr get cancelled, plus q minus q get cancelled, plus r minus r get cancelled, and in this way we get, that is the, now see this, that is a raised to 0 into r raised to 0, and that's equals to 1, and that's why its value is 1. Now next, therefore x raised to q minus r, y raised to r minus p, z raised to p minus q equals to 1. Hence, it is proved. Now, next example, that is a question number 22. Which two terms are inserted between 5 and 40 so that the resulting sequence is GP. Now, this is a very simple problem. Let x and y be two terms, that is a 5, x, y, 40. Now, the x and y are the two terms in between 5 and 40. Now, in this case, the common ratio is x upon 5, y upon x, and the 40 upon y is constant. Therefore, if we take x upon, now we will take in this manner, that is x upon 5 is equals to y upon x, and y upon x is equals to 40 upon y. Therefore, x square is equals to, and the last is first and last, that is the first two, second, third, and first and last here. We will take these two ratios. First of all, x upon 5 is equals to y upon x. Now the cross multiplication, x square is equals to 5y, y square is equals to 40x, and xy is equals to 40 into 5, that is 200. Now y square is equals to 40 into x, and xy is equals to 200. Therefore, x is equals to 200 upon y, and that's why is equals to y square is equals to 200 into 200 upon y square is equals to 40 into 200 upon y, and that's equals to, this is the calculations, that is y square is equals to 8000 upon y. Now this is the divided, now it will come to the multiplied, that is the y cube is equals to 8000, and that is nothing but 20 cube. Therefore, y is equals to 20. Now next, xy is equals to 200. Therefore, x is equals to 200 upon y. That is a 200 upon 20, and that is equals to x is equals to 10. Y is equals to 20, and these are the two terms, that is the 10 and the 20. Now the next example, question number 28. If PQ are in GP and P raised to 1 upon x is equals to Q raised to 1 upon y is equals to R raised to 1 upon z. Verify whether x, y, z are in AP or GP or neither. Now see this here. we have, that is a p raised to 1 upon x is equals to q raised to 1 upon y is equals to r raised to 1 upon z, that is equals to k. Therefore, next is p is equals to k raised to x, q is equals to k raised to y, and r is equals to k raised to z. Now, how this come? That is a p is equals to 1 upon x is equals to k. Then take the power on both sides. P raised to 1 upon x whole bracket raised to x is equals to k raised to x. Then x will get cancelled, and then you will get p is equals to k raised to x, and similarly y is equals to k raised to y, and r is equals to k raised to z. Now PQR are in GP, therefore they have the common ratio. PQR, these are, that is a Q upon P is equals to R upon Q, that is a Q square is equals to PR. This is the first. From first and second, now see this here, PQ are in GP, therefore Q upon P is equals to R upon Q is equals to Q square is equals to PR. Now we will substitute here the value of Q. The value of Q is k raised to y and whole bracket raised to 2 is equals to P into R, where P is k raised to x and R is k raised to z. Therefore, we will get that is k raised to 2y is equals to k raised to x plus z, and that's why 2y is equals to x plus z and y is equals to x plus z upon 2, and that's why x, y, z are in AP. When x, y, z are in AP, then y is equals to z plus x upon 2, and that's why we say that x, y, z are in AP. Now the next is question number 29. If A, B, C are in geometric progression and ax square plus 2bx plus c equals to 0 and px square plus 2qx plus r equals to 0 have the common roots, then verify that pb square minus 2qba plus ra square equals to 0. Now see this, the roots of the quadratic equations ax square plus 2bx plus c equals to 0 are the, here we will apply the formula, that is a, what is the basic formula? Ax square plus bx plus c is equals to 0, then x is equals to minus b plus or minus in root of b square minus 4ac, but here b is 2b, therefore we take here minus 2b plus or minus in root of 2b square minus 4ac upon 2a. Now here we will simplify, but ABC are in GP, Therefore, B square is equals to AC. We'll substitute the value in above equation, that is the minus 2B, and here that is a 4B square minus 2BC. But B square is equals to AC. If we substitute here, therefore it is a 4AC minus 4AC. This whole quantity becomes 0. 2 get cancelled, and you will get x is equals to minus the value of x is equals to minus b upon a. Therefore, px square. Now this is also the root of this quadratic equation. Px, this equation, that is a px square plus, we'll substitute here, replace the value, that is a, now here that is a p in bracket the value of x plus 2q the value of x plus r, and now we will simplify here, that is p dot b square upon a square minus 2 bq upon a plus r equals to 0. That is a pb square. Multiply on both sides by here a square, a square, a square, and a square. Here it will become ar square. Here it will become minus 2bqa, and here pb square. Next, question number 13. If PQ are S are in GP, show that P square plus Q square plus R square into Q square plus R square plus S square, and that is equals to PQ plus QR plus RS bracket square. Now we'll simplify here. Let R be the common ratio, but instead of this common ratio, we will replace here, that is R by K, because R is repeated here number of the times. Now I am changing it. That is K be the common ratio of GP. Then Q upon P is equals to K. Now see this, PQRS are in GP, therefore Q upon P is equals to K, R upon Q is equals to K, S upon R is equals to K. Now see this, Q is equals to PK, R is equals to QK, S is equals to RK. Therefore, now we'll substitute the value. Now the basic value of the Q is Pk, R is equals to Qk. The value of Q is Pk into K, that is a Pk square. And the value of S is equals to, it will be Pkq. Now see this here, S is equals to Pk into K, that is a Pkq. Therefore, Q is equals to Pk, R is equals to Pk square, and S is equals to Pkq. Therefore, now we will substitute these values in above equation. That is the p square plus q square plus r square in bracket q square plus r square plus s square. Now substitute the values. Now first of all, the value of p is as it is. The value of q is pk, that is the p square q square, and the value of r is pk square. Substitute the value, that is a p square into k raised to 4. Again the q square, that is a p square k square plus r square means what? P square k raised to 4. S square means what? P square k raised to 6. Now we'll take the common. The common terms are from the first bracket we will take the common p square. Then in bracket you will get 1 plus k square plus k raised to 4. And from the second bracket you will take the common, that is the p square and the k square. Now see this. Therefore you will get p square k square is a common. Then in bracket 1 plus k square plus k raised to 4 that is equals to p raised to 4 k square 1 plus k square k raised to 4 and whole bracket square. This is equation number 1. And RHS is equals to, that is PQ plus QR plus RS bracket square. Now here we will substitute the values. The value of P is as it is. The value of K is PK plus value of here Q. We are substituting the value of P is a PK. Value of R is a PK square. Value of R is PK square and the value of S is PKQ and whole bracket raised to 3 bracket square. Now we'll take the common. What are the common terms? That is a p square k. P square k plus p square k cube plus p square k raised to 5 bracket square. Therefore here you will get that the p square in bracket, that the p square k will be common. Now see this here. We have taken, see this here, we have taken the p square k as a common. Then in bracket you will get 1 plus k square plus k raised to 4 bracket square. Now, see this again. Next, p raised to 4 k square. 1 plus k square plus k raised to 4 bracket square. This is number 2. Now see this here. Square of this p square, that is the p raised to 4 k square, 1 plus k square k raised to 4 and bracket square. Therefore from 1 and 2 LHS is equals to RHS. Hence it is proved. That is a PQ square plus R square plus A square is equals to PQ plus QR plus RS bracket square. Now the next is question number 31. If PQRS are in GP, show that p raised to n, q raised to n, comma, q raised to n plus r raised to n. Next, r raised to n plus s raised to n are also in GP. That is, now see this here, p, q, r, s are in GP. Then p raised to n plus q raised to n, q raised to n plus r raised to n, r raised to n plus h raised to n are also in GP. Now, p, q, r, s are in GP. Let k be the common ratio. Therefore, q upon p is equals to k, r upon q is equals to k, s upon r is equals to k. Therefore, here is q is equals to pk, r is equals to qk, and s is equals to rk. Again, we will substitute the values here. Now, see this. That is here p is equals to qk and r is equals to qk. We will substitute here the value of q is pk into k, that is the pk square. Next is s is equals to rk. The value of r is pk square into k, that is the k raised to 3. Now, see this here. P raised to n plus q raised to n. Now, p raised to n will be as it is because its value is as it is. Next, q, the value of q is a pk bracket raised to n. That is p raised to n, p raised to plus p raised to n, k raised to n. And from these two, we will take the p raised to n as a common. Then in bracket 1 plus k raised to n. Therefore, p raised to n plus q raised to n is equals to p raised to n in bracket 1 plus k raised to n. Now, next, q raised to n plus r raised to n. The value of q is, that is, p raised to n, k raised to n plus the value of r is p raised to n, k raised to 2n. We will take the common p raised to n, k raised to n in bracket 1 plus k raised to n. And last is r raised to n, s raised to n. The value of r is p k square. It means that p raised to n and k raised to 2n. The value of s is p raised to n and k raised to 3n. That is it. Therefore, p raised to n, k raised to 2n plus p raised to n and k raised to 3n. Now, we will take p raised to n as a common and k raised to 2n. Then in bracket, you will get 1 plus k raised to n. That is r raised to n plus s raised to n. That is equals to p raised to n into k raised to 2n in bracket 1 plus k raised to n. Now, see these values. First, 1, 2, 3. These are the two values, 3 values. That's we have find out it. Now, q raised to n plus r raised to n upon p raised to n plus q raised to n is equals to. Now, here we will substitute their values. See this here, q raised to n, r raised to n. The value is p raised to n, k raised to n in bracket 1 plus k raised to n. P raised to n, q raised to n. Then in bracket you will get p raised to n in bracket 1 plus k raised to n. Next is, and overall you will get k raised to n. The next value is, that is, I am writing again it, the value is k raised to n. This is the first. Now next, also r raised to n plus s raised to n upon q raised to n plus r raised to n. Now here we will substitute the value. The value of r raised to n, r raised to n and s raised to n, that is a p raised to n into k raised to 2n in bracket 1 plus k raised to n. And next value is q raised to n plus r raised to n. It's from here, that is the p raised to k, and this is the value. Now from 1 and 2, these two are equal, and hence their left hand sides are also equal. Therefore from 1 and 2, the ratio is constant. Therefore p raised to n, q raised to n, and next is q raised to n plus r raised to n, r raised to n plus s raised to n are also in GP. Next is 32, question number. Find the coefficient of x raised to 6 in the expansion of e raised to 2x using the series expansion Now let us start. That is e raised to x is equals to 1 plus x upon 1 factorial, x square upon 2 factorial, x cube upon 3 factorial, and x raised to 4 upon 4 factorial. But here we will require x raised e raised to 2x. Therefore, x is replaced by 2x. Now see this here. That is x is replaced by 2x. X is replaced by 2x cube upon 3 factorial. X is replaced by 2x raised to 4 upon 4 factorial. 2x raised to 5 upon 5 factorial. And 1 plus 2 upon 1 factorial into x. 2 square upon 2 factorial into x square. 3 cube upon 3 factorial into x raised to 3. 2 raised to 4 upon 4 factorial into x raised to 4, and in this way, that is a 2 raised to 5 upon 5 factorial into x raised to 5, and in this way. Now here we will require here that is, we will take one more extra term here. That is a 2x raised to 6 upon 6 factorial. That is a 2 raised to x into x raised to 6 upon 6 factorial, and in this way. Therefore, the coefficient of x raised to 6 is 2 raised to 6 upon 6 factorial. Therefore, its value is 2 into 2 into 2 up to the 6 upon 6 factorial means what? 6 into 5 into 4 into 3 into 2 into 1. here is the cancellations, and that is equals to 4 upon 45. Therefore, coefficient of x raised to 6 is 4 upon 45. Now the answer given in the textbook is different from my answer. If you are agree, then write down. If you are not agree, then you don't write this. Now next is question number 33. Again, the answer of this question is different from the textbook. I had solved in my way. If you like this, then write down this answer also. Now 1 plus 4 upon 5 plus 7 upon 25 plus 10 upon 125 plus 13 upon 625 dash dash the infinity. Now here s is equals to 1 plus 4 upon 5 plus 7 upon 25 plus 10 upon 125 plus 13 upon 625. Now in this sequence, that is we write here 1 plus 4 upon 5, 7 upon 5 square plus 10 upon 5 raised to 3 plus 13 upon 5 raised to 4. Now multiply on both sides by 1 upon 5. Therefore, 1 upon 5 into s is equals to 1 upon 5 in 1 upon 5s is equals to 1 upon, in that is, we'll take in bracket 1 upon 5 plus into in bracket 1 plus 4 upon 5 plus 7 upon 5 square plus, and in this way you will get the terms like this, that is 1 upon 5 plus in bracket 4 upon 5 plus 7 upon 5 square plus 10 upon 5 cube plus 13 upon 5 raised to 4 dash dash in this way. Now next is that is 1 upon 5 plus 4 upon 5 square plus 7 upon 5 cube plus 5 is 10 upon 5 raised to 4 plus 13 upon 5 raised to 5. Now in this case again we will treat the first term as 0 plus 1 upon 5 plus 4 upon 5 square plus 7 upon 5 cube plus 10 upon 5 raised to 4 plus 13 upon 5 raised to 5. Therefore, you will get, this is the equation number 2. Now equation 1 minus equation 2, that is s minus s upon 5, that is equals to 1 minus 0 plus 1 minus, now here is a subtraction, 4 upon 5 minus 1 upon 5. Next is 7 upon 5 square minus 4 upon 5 square, and in this way 10 upon 5 cube minus 7 upon 5 raised to 3, that is equals to 4s upon 5, that is equals to 1 plus 3 by 5 plus 3 by 5 square 3 upon 5 cube plus dash dash, and in this way keep this first term as it is, and from the remaining term take 3 as common. Then in bracket you will get 1 upon 5 plus 1 upon 5 square plus 1 upon 5 cube dash dash, and in this way. Now see this here, 1 plus 3 in bracket. Now this is in the geometric progression, infinite terms are there. A is equals to 1 upon 5 plus, and r is equals to 1 upon 5, therefore 1 upon 5 upon 1 minus 5, 1 upon 5 upon 1 minus 1 upon 5. Now simplify this. That is 4 upon 5. 5 get cancelled. You will get that 3 into 1 by 4, and that is equals to 7 upon 4. Therefore, 4s upon 5 is equals to 7 upon 4, and that's why s is equals to 35 upon 16. The value of s is 35 upon 16. Again, the answer in the textbook is different. I had solved this in this way. If you are agree, then write down this answer. If you don't like, then you don't write. And in this way, we have completed the miscellaneous exercise for this sequence and series. And now my next video will be for the trigonometry 2. Now we'll see in the next video. Till then, goodbye. And in this way, we have completed the miscellaneous exercise for the sequence and series. I hope that you understood all the questions, whatever that I had explained. And if you like my work, then share it with your needy friends. And also, if you are new for this channel, and if you like this my video, then subscribe it and share it with your needy friends. We'll see in the next video. Till then, goodbye.